This is mathheals.com. If you want to come here to get more YouTube math videos, there's links to them here. Let's take a look at matrix solutions to linear systems. And let's first talk about what a matrix is. A matrix is a rectangular array of numbers looks something like this. You have brackets around it, and then you have individual numbers inside. And each one of these is in their own cell. It's kind of like a spreadsheet, if you think of it that way. It has a size that goes along with it. Size is also called order. And it goes by rows by columns. So for this particular one, we have 2 rows and 3 columns. So it'd be a 2 by 3. Now usually matrices are represented by capital letters like capital A, capital B, so forth. When you're referencing individual entries in the cell or in the matrix, you represent it with lowercase a, and then this represents your rows and columns. So that's how you can represent each individual entry if you wished. Now we're going to be taking a look at solving systems of equations that look like this by using matrices. And we're going to have to put it into matrix form. Now in matrix form we drop the variables and equals and keep the numbers in their signs. So we'd have 3, -5, 2. We'd have 4, 7, and 3. And now this is the form I like, but the book will, some books will put extra lines like that. That separates where the equals is. Some books will draw a line all the way down like that. So I don't really care what you do in that regard. I'm just going to go ahead and leave it blank like that. And this right here is called our augmented matrix. So augmented matrix. And these first problems just want us to work with that. So let's take a look at the first one. We have 9x minus 3y plus 4z equals 15. X plus 2y minus z is equal to -23. Negative 3x minus y plus z is equal to 18. I'm just double checking all my signs. Okay, and the instructions on this are to write down the augmented matrix for each system of linear equations. Well, for this one, we'll drop our x's, y's, and z's and equals and keep the numbers in their signs. So we got 9, -3, 4, 15, 1, 2, -1, -23, -3, -1, 1, and 18. And let me double check my signs. And that'd be our answer. Let's take a look at another one of those. Got x minus 4y plus 2z is equal to 3. 5x plus y is equal to 7. And 9x minus 3z is equal to 1. And assuming I typed in, yeah, I got all my... Now this one's a little bit harder to write down the augmented matrix. The last one was easy because we weren't missing any variables, and all the x's lined up nice, the y's lined up nice, and the z's lined up nice. Well, here we're missing some variables. So when we put it into matrix form, we need to make sure we put all the x's in one column, all the y's in one column, all the z's in one column, and the number on the other side of the equals in one column. So our first row here, we'll have 1, -4, 2, and 3. We'll have 5, 1, and we're missing the z, so we'll put a 0 there, and then 7. Last one, we have 9, we're missing the y, so we'll put a 0 there, and then -3 and 1. And assuming I didn't screw up on the signs, that would be our answer. On this one, we're given the augmented matrix. 2, 0, 3, 7, 0, 2, -4, 5, 3, 4, 0, -1. It says, write the system of linear equations represented by the augmented matrix. Use x, y, and z if necessary, or if necessary, w, x, y, and z, depending upon how many variables you need. What we're going to do is we're going to put the x, y's, and z's back in there and equals. So this is x, y, z equals. X, y, z equals. X, y, z equals. So we'd have 2x. Now the 0y drops away. Plus 3z is equal to 7. 0x drops away, and we got 2y minus 4z is equal to 5. And 3x plus 4y, and the 0z drops away, is equal to -1. And that would be our answer. Now for matrices. Once you get it in matrix form, you can perform row operations. And I'll talk more later why we want to do this. Different row operations you can do. You can multiply or divide. And these row operations are specific to solving systems equations, which is what we're going to do here shortly. Not all of these apply in some of the other circumstances. But we're going to multiply or divide, or you can multiply or divide everything in a row by a number. You can swap two rows. Now again, that only applies when you're dealing with solving systems linear equations like we're going to be doing. You can add one row to another row. You can multiply or divide a row by a number. And add it to another row. Now when you do this fourth operation, you don't actually change the original row. You just multiply by a number and then add it to another row, and that original row stays the same. And we'll see what in the world I mean by that in terms of the original row. Let's take a look at this problem. And let me start a new page. Okay, number 4. And we got 5, -20, -10, 2, 7, -1, -3, 7, -1, -3, 4, 2, 8, 2, -2. And it says we want to do 1/5 times row 1. What that's saying is we want to take 1/5 times all the numbers in row 1, and that's going to give us our new row 1. That's implied when they have that notation. So we're going to go ahead and multiply 1/5 times all the numbers in row 1. So we got 1/5 times 5. We got 1/5 times -20. 1/5 times negative 10, and 1/5 times 2. And the other rows stay the same. Well, 1/5 times 5 gives us 1. 1/5 times negative 20 gives us negative 4. 1/5 times negative 10 gives us negative 2. 1/5 times 2 gives us 2/5. And all the rest of this stays the same. Like that. So again, you can multiply or divide everything in a row by a number. That's what this one's demonstrating. Let's take a look at another row operation. We got 4, negative 2, 3, 1, 5, negative 1, negative 2, 9, 1, 2, 7, and negative 3. And the instructions say to take negative 2 times row 1 and add that to row 2. Excuse me. Okay, so negative 2 times row 1 plus row 2. What that's going to do is that's going to give us our new row 2. Row 1 does not change. So when we're saying take negative 2 times row 1, we're not actually saying physically do it right up here. We're saying take it off on the side and in your head, take negative 2 times row 1, then add it to row 2. Well, let me show that. Negative 2 times row 1. Row 1 is 4, negative 2, 3, and 1. Plus row 2, which is 5, negative 1, negative 2, and 9. Well, negative 2, and I multiply it through. I get negative 2 times 4, gives us negative 8. Negative 2 times negative 2 is 4. Negative 2 times 3 is negative 6. Negative 2 times 1 is negative 2. Just double checking myself on these. There we go. Okay, now add these two together. So negative 8 and 5 gives us negative 3. 4 and negative 1 gives us 3. Negative 6, negative 2 is negative 8. And negative 2 and 9 gives us 7. And again, I'm going to double check myself here. And that's our new row 2. So our matrix now becomes, we got 4, negative 2, 3, 1. We got 1, 2, 7, and negative 3. And our new row 2 is negative 3, 3, negative 8, and 7. And that'd be your answer. Now we're going to have three ways we're going to solve systems of equation. Now we're going to have system of equations here, and then we'll write down the augmented matrix that goes along with them. And then we're going to continue it down, and let me give you an actual example here. It'll mean more. We'll come up with through row operations. We're going to come up with something of this form. This stands for row echelon form. And let me scratch my eye here. I'm going to take my glass. Well, yeah, I'll try leaving them off. What row echelon form says, it actually says more than this, but in terms of what we're going to do with it for solving systems of equations, row echelon form means you'll have a diagonal of 1s, and then you have zeros below those 1s. And then these little dashes here represent any numbers. Now, row echelon form is more than that, but for purposes what we're going to be working with, that's what will happen. row echelon form, if you go on and take other linear algebra classes, they do not have to be in a straight diagonal. But your first number that isn't 0 in a row has to be 1. And you can't have like this one here, it can't be before this one. So there's some rules along with it. But again, think diagonal 1, 0's below. Then after we get that, we're going to put that into backwards substitution. And use that to come up with our answers. Now the second way we'll do it through 3 ways actually, but the second way is we start with our systems of equation. System of equations. We'll put it into our augmented matrix form. And through our row operations, we're going to end up with a diagonal of 1s, 0's below it, and 0's above the 1s. And then we'll have some number over here. And when we do that, these are going to be our answers in the far right column. This is RREF, and this is reduced row echelon form. Now this first one here is referred to as Gaussian elimination. So that's going to refer to as Gaussian elimination. This one is Gauss-Jordan elimination. So remember, REF, 1R, diagonal 1, 0's below it. RREF, diagonal 1, 0's below it, 0's above them. And then the answers will just be there. Then our third method is a calculator, which we'll look at. Let's look at our first problem. And I'm going to do this first one three different ways. So you'll see the different methods. Number 6 says solve each system equations using matrices. It says use Gaussian elimination with back substitution or Gauss-Jordan elimination. Well, we're going to do the first one with Gaussian elimination with back substitution. Okay, so this is Gaussian elimination with back substitution. So we're going to go backwards and substitute things in. Okay, and this is number 6. So we got x minus 5z equals negative 4. 3x plus 4y minus 2z is equal to 9. 2x minus 4y plus 3z is equal to negative 3. And let me go to double check everything. Signs all look alright. Okay, so first thing we need to do is write down a matrix. So we'll write down our augmented matrix. We got 1 here, we're missing the y, so that's 0. Negative 5, negative 4. 3, 4, negative 2, 9. 2, negative 4, 3, and negative 3. And I'll be kind of going slow through this, double checking my signs and everything. Looks good. Okay, first step. We want to get a 1 here. Now, if that wasn't a 1, then we could divide everything in this row by that number. Like if this was a 2, for example, I would divide everything in the first row by 2. But we're fine there. Okay. Second step, we want to get zeros below that 1. So we want to work at getting zeros right there. And let me double check my signs. 1, 0, -5, -4, 3, 4, -2, 9, 2, -4, 3, -3. Okay, looks good. I make mistakes on these so easy. I was creating this video earlier today. Had it down. You know, everything was going real good. You know, everything seemed to be flowing real smooth. 67 minutes into the video, I worked the problem wrong. And then I thought, well, I'm going to find out where I went wrong. I went back and looked, could not find it. It looked like I'd done everything perfect. What I had done is I'd went from a -5 here, and I dropped the negative, made it a +5. I dropped signs so easy on these. I was disgusted. I deleted it. Now I'm trying again. So again, I'm going to be really careful about my signs here. Okay, we're looking at this 1 right here. We're asking, what do we multiply times that 1 that we then would add to this 3 to get a 0 here? Well, if we multiply this by -3, -3 times 1 is -3, and we add it to the 3, we'd get a 0 here. So we're going to take -3 times row 1, and we'll add it to row 2 to give us our new row 2. Now look at the 1 here, and I'm looking at the 2. I'm asking myself, what times the 1 that then added to the 2 gives me a 0 here? Well, if I multiply the 1 by -2, -2 times 1 is -2, plus 2 would give me a 0. So we're going to take -2 times row 1, and we'll add it to row 3 to give us our new row 3. Okay, -3 times 1. -3 times 1 is -3, plus 3 is 0. -3 times 0 is 0, plus 4 is 4. -3 times -5 is 15, minus 2 is 13. -3 times -4 is 12, plus 9 is 21. Okay, now the -2 times row 1 plus row 3. So -2 times 1 is -2, plus 2 is 0. -2 times 0 is 0, plus -4 is -4. -2 times -5 is 10, plus 3 is 13. -2 times -4 is 6, plus -3 is 3. Now I'm going to go through and double check myself. -3, okay, 0, 4, 15 minus 2 is 12, okay. That's 12 plus that's 21, okay. And not, carry the not. Okay, -4, 10, 13, 8, 5. Ooh, wait a minute. -2 times -4 is 8. Added to -3 gives me a 5. Okay, now I'm going to double check myself. That's not good. So -3 times row 1 is -3, plus 3 is 0. -3 times 0 is 0, plus 4 is 4. -3 times -5 is 15, plus -2 is 13. -5 times, or -3 times -4 is 12, plus 9 is 21. Okay, -2 times 1, and then add to that. -2, okay, -4. -2 times -5 is 10, plus 3 is 13. -2 times -4 is 8, minus 3 is 5. Not a good feeling. I made a mistake early on. I hate these. By hand. I screw up so easy on making a basic math error. Okay, now what we want is we want a 1 here. Because we're working our way down. We're trying to get a diagonal of 1s. Well, we can divide everything in row 2 by 4. So I'm going to take row 2, divide by 4, and that gives me my new row 2. 0 divided by 4 is 0. 4 divided by 4 is 1. 13 divided by 4 is 13 fourths. 21 divided by 4 is 21 fourths. Okay. Then we'll get zeros below it. So we want a 0 here. Okay. If I look at the 1, I ask myself, what do I multiply times the 1 that then can add to the negative 4 to get 0 there? Well, if I multiply this 1 by 4, 4 times 1 is 4, plus negative 4 is 0. So we're going to take 4 times row 2 and add that to row 3, and that's going to give us our new row 3. Okay, 4 times 0 is 0 plus 0, 0. 4 times 1 is 4 plus negative 4 is 0. 4 times 13 fourths gives me 13 plus 13 is 26. 4 times 21 fourths is 21 plus 5 is 26. Okay, now we're working our way down, getting a diagonal of 1s. So diagonal of 1s, we need a 1 here now. So let's work on that. Had lunch with an old friend today, my old boss when I was a computer programmer, and I was telling her about creating this video and having to screw up 67 minutes into it, and I was being so careful there. She said, "What? Well, don't you have it written down?" And I said, "Well, I don't like that. I don't like going off of script. It's not as much fun for me. And if it's not fun, I won't do it." So, well, I want a 1 here. I can divide everything in this row by 26. So we'll take row 3, divide by 26, and that's going to give us our new row 3. Well, 0 divided by 26 is 0. 0 divided by 26 is 0. 26 divided by 26 is 1. 26 divided by 26 is 1. Okay, now I need to get a piece of paper so I can write this down. I thought I had one handy here. Almost got mad earlier and ripped it up. Oh, here it is. Actually, I already have this written down from earlier. Well, that's a good sign. The same thing I had written down earlier. I'm going to continue the problem up here. So 1, 0, negative 5, negative 4, 0, 1, 13 fourths, 21 fourths, 0, 0, 1, 1. Now this is REF format, row echelon form. That means you got a diagonal of 1, zeros below it. So if you look at that there, actually I don't want to draw on that. What we're going to do now is we're going to put our x, y's, and z's back in there. So this is x, this is the backward substitution part. This is y, this is z, and here's our equals. This is x, y, z, and equals. X, y, z, and equals. So this first row, we have 1x or x plus 0y. The 0y drops away. Minus 5z is equal to negative 4. 0x drops away, and we got 1y or y plus 13 fourths z equals 21 fourths. 0x and 0y drops away, and we got 1z, or just z, is equal to 1. Okay, now starting with our last equation, it's actually already solved for z, isn't it? So we're fine there. Now we're going to do back substitution, so we're going to plug it in backwards. We're going to take the z equals 1 and plug it into the equation right above it. So we got y plus 13 fourths z equals 21 fourths. And we just said that z is 1. Well, 13 fourths times 1 is 13 fourths, so I'll move that to the right side, and we got 21 fourths minus 13 fourths. (21 minus 3 is 8 fourths, or y is equal to 2. Well, now we have these two, so we want to go back and plug it, both of those into the equation right above that. So we're going backwards. So x minus 5z is equal to negative 4. Now this one works out even nicer because we don't have a y in our first equation, so we'll just that doesn't always work that way. So then we'll plug 1 in for the z, and we got x minus 5 equals negative 4. Take the negative 5 to the right side, becomes a positive 5 minus 4. And we get x equals 1. Now those are answers. Usually your answer is written with parentheses around them, and then your first answer, the 1, 2, and then 1. So you put x, y, z. And that would be your answer. And let me grab a drink here. And we're going to do this problem again. And probably just be just easy to start a new page. And this time we're going to use Gauss-Jordan elimination. This is the way I usually like if I'm going to do it by hand. I don't like back substitution. You got x minus 5z is equal to -4. 3x plus 4y minus 2z is equal to 9. 2x minus 4y plus 3z is equal to -3. And let me double check all my signs. Since I screwed that up earlier, I want to be really careful about signs this time. Okay. And I want to write down the augmented matrix goes with it. So I got 1, 0, -5, -4. I got 3, 4, -2, 9. 2, -4, 3, and -3. Okay. Let's go through our steps now. Our first step, we want to get a 1 here. Well, we have a 1 there, so that's okay. I'll write it down again. Now what we want to do is we want to get zeros below that 1. So we want to work on getting zeros there. Again, we asked the same question we did before. You ask, what do you multiply by this 1 that you can then add to the 3 to get a 0 there? Well, we multiply that by -3. -3 times 1 is -3, plus 3 would give us 0. So we're going to take -3 times row 1. We'll add that to row 2, and that gives us our new row 2. Let me go ahead and do it, and then I'll work on the next one. -3 times 1 is -3, plus 3 is 0. -3 times 0 is 0, plus 4 is 4. -3 times -5 is 15, minus 2 is 13. -3 times -4 is 12, plus 9 is 21. 15, 13, 12, okay. Now our next one, we want 0 here. So I'll multiply this by -2, and that would give it to me. So -2 times row 1, added to row 3, gives us our new row 3. -2 times 1 is -2, plus 2 is 0. -2 times 0 is 0, plus -4 is -4. -2 times -5 is 10, plus 3 is 13. -2 times -4 is 8, plus -3 is 5. I think that 5 is what I screwed up on the previous, the one I just did about 10 or 15 minutes ago. But let me double check this. Instead of sitting there talking. Blah, blah, blah. Okay, that looks good. Now what we want, these first steps are the same in case you're wondering. We want a diagonal, or a diagonal of 1, so we want a 1 here. Okay. So we're going to divide everything in this row by 4. So we're going to take row 2, divide by 4, gives us our new row 2. 0 divided by 4 is 0. This is 0 here. 4 divided by 4 is 1. 13 divided by 4 is 13 fourths. And 21 divided by 4 is 21 fourths. Okay. Next step. Get a 0 below that 1. 1, 0, negative 5, negative 4, 0, 1, 13 fourths, 21 fourths. Okay, I look at this 1 here. And you ask, what do you multiply by that then add to this gives you 0? If I multiply that by 4, 4 times 1 is 4, plus a negative 4 is 0. So we're going to take 4 times row 2 and add it to row 3 to give us our new row 3. 4 times 0 is 0, plus 0 is 0. 4 times 1 is 4, plus negative 4 is 0. 4 times 13 fourths is 13, plus 13 is 26. 4 times 21 fourths is 21, plus 5 is 26. Okay. Again, we want our diagonal 1s, so the next logical, here's my 1s going down, I need a 1 here. So, for row 3, I'm going to take row 3 and divide everything by 26. And that's going to give us our new row 3. 0 divided by 26 is 0. 0 divided by 26 is 0. 26 divided by 26 is 1. 26 divided by 26 is 1. And that's a very good sign, because that's actually what I have written down on my piece of paper here from earlier. Because I had to write it down in order to carry on my problem up here. Okay, so let's continue going. So we've got 1, 0, negative 5, negative 4, 0, 1, 13 fourths, 21 fourths, 0, 0, 1, 1. Okay, now our steps, we got a 1 here, got zeros below it. We got a 1 here, zeros below it. We got a 1 here, there's nothing below it, so we didn't need to get zeros. Now going on with this, we start at the bottom 1 here, and you get zeros above it. So I want to get zeros in these two places. Okay, so I look at this 1 here, I ask myself, what do I multiply by? I then can add the 13 fourths to get a 0 there. Well, I multiply it by negative 13 fourths. So we'll take negative 13 fourths times row 3, and we'll add that to row 2 to give us our new row 2. Let me go ahead and do that. Negative 13 fourths times 0 is 0, plus 0 is 0. Negative 13 fourths times 0 is 0. Plus 1 is 1. Negative 13 fourths times 1 is negative 13 fourths plus 13 fourths, gives us 0. Negative 13 fourths times 1 is negative 13 fourths plus 21 fourths, gives us 8 fourths. Okay. Now I'm looking at this 1 here, and I'm asking, what do I multiply times this 1 that then can add to this negative 5 to give me a 0 here? Well, that'd be 5. So I'll take 5 times this, 5 times row 3, and add that to row 1 to get us our new row 1. 5 times 0 is 0, plus 1 is 1. 5 times 0 is 0, plus 0 is 0. 5 times 1 is 5, plus negative 5 is 0. 5 times 1 is 5, plus a negative 4 gives us 1. Okay. So we started with this 1, we got zeros above it. So now we're going to go to our next 1, and we want to get zeros above it. So we're going to work at getting a 0 there. Now this problem already has it, so we're fine. But we do the same kind of thought process as before. We'd ask ourselves, what times row 2 that added to this would give me a 0 here? So what we're left with is we got 1, 0, 0, 1, 0, 1, 0, 8 divided by 4 is 2, 0, 0, 1, 1, like that. Now, RREF, reduced row echelon form, means that if I got 3 equations and 3 variables, I'm going to have a 3 by 3 here that's a diagonal of 1, zeros everywhere else, which is what I have. And if you have that, your answers are the far right column. So our answers would be 1, 2, 1. X, Y, Z. If you're wondering the order of your answers, well, the reason why this is X and this is Y and this is Z, X, Y, Z, is because that's the order I put into my matrix. I put the x's in the first column, y's in the second, z's in the third. So this has to be x, this has to be y, and this has to be z. And we get the same answer as we did before. Okay, that's Gauss-Jordan elimination. Let's look at the calculator. Probably the easiest way. So we write down the problem again. I didn't have any problem with this one earlier. This one went real easy. It's the next one I screwed up on with the sign. So we got 3x plus 4y minus 2z equals 9. 2x minus 4y plus 3z is equal to negative 3. And let me double check all my signs. Okay, that looks good. So solving system of equations, specifically linear. System of equations. I actually got plenty of sleep last night, I think. Solving a system of equations using the TI-83 84. Okay, first step. Input the matrix. And then we'll do a second mode to exit out once we're done. A lot of people forget that second mode part. Then we'll go into the matrix menu. We're going to right arrow to math. And we're going to up arrow to RREF. And you have to make sure you choose the one with 2 R's. The one with 1 R is for backward substitution. It won't work when we're solving systems equations. And after we up arrow to it, we'll press enter. And then we're going to go back into our matrix menu. And we'll do enter on A. And then we'll do enter again. And step 3. If you have decimals, you'll do math, enter, enter. So math, enter, enter. Let me grab a drink here before we do this. Okay. Well, we need to write down the augmented matrix that goes along with this. So this is 1, 0, negative 5, negative 4, 3, 4, negative 2, 9, 2, negative 4, 3, and negative 3. Check my signs real quick. Looks good. Remember our size of our matrix. Rows by columns. This is a 3 by 4. And actually, I should already have this in my calculator since I did this earlier. But let's see. Look at that. I even solved it earlier. Okay. To go into my matrix menu, it says input your matrix. You see above the X and negative 1 key, it says matrix. That's actually your inverse button. But we'll press second, X and negative 1. And we input our matrix under the edit. So I'm going to right arrow twice, go over to edit. And A is already highlighted, and that's as good a place as any to put it. So I'll go ahead and press enter on A. Now you may or may not have numbers here. Don't get really upset and try and figure out how to get rid of them. As you type in your new numbers, it'll overwrite the old ones. We said this was a 3 by 4, so do 3, enter, 4, enter. And we're going to type in each number pressing enter after it. It's 1, enter, 0, enter, negative 5, enter, negative 4, enter, 3, enter, 4, enter, negative 2 inner, 9 inner, 2 inner, negative 4 inner, 3 inner, negative 3 inner. Now I'm going to use my arrow keys to double check myself. Okay, all looks right. Now notice I put second mode here. You have to be sure you exit out after you get that in. So do second mode, exit out. Now we're at step 2. Go back in the matrix menu. So do second, x to negative 1. It says right arrow to math. So we're going to right arrow to math. It says up arrow to RREF. So I'll press my up arrow and keep going until I get to RREF. Make sure you choose one of 2 R's. And then it says press enter. Then it says go into matrix menu again. So second, x to negative 1. On a T83, not a T83 plus, but a T83, you actually have a matrix button. So it's a little easier for you. Enter on A. So enter. Then it says do enter again. And that's what we get. So let me write that down. Probably looks familiar, doesn't it? That's the same thing we did when we did Gauss-Jordan elimination. Now again, if you got 3 equations, 3 variables, your first 3 by 3 matrix should be a diagonal of 1s, 0s everywhere else. And another lesson, we'll look at how to handle the oddball cases, like infinite solutions, no solution, and what it looks like with these. Now again, our right column is our answers, so it'd be 1, 2, 1. Same as the last few times we worked this problem. So that's how you do it on a calculator. Okay. Back to the problem that'll give me nightmares. I'm going to do this. Originally, I had the brilliant idea to do it 3 different methods. I was going to use Gaussian elimination with back substitution, Gauss-Jordan elimination, and then the calculator. Well, I'm just going to use Gauss-Jordan elimination, and then I'm going to use a calculator. And hopefully I don't screw up on a sign this time. Famous last words. That's what I was saying last time. Okay, so let me go ahead and write down my matrix. 1, 1. Negative 2, 3, 16. 3, negative 1, negative 1. 5 and 18. 1, 2. Negative 3, negative 4. Negative 9. 1, negative 5. Negative 1, negative 2, and negative 12. Okay, let me double check my signs. 16, 18, negative 9, negative 12, 3, 5, negative 4, negative 2, negative 2, negative 1, negative 3, negative 1, 1, negative 1, 2, negative 5, 1, 3, 1, 1. Okay. First step. We want to get a 1 here. Well, we got a 1 there, don't we? Going to write down everything again, being really careful this time not to drop a sign. Okay, let me double check signs. 3, negative 1, 5, 18, negative 9, negative 4, negative 3, 2, 1, 1, negative 5, negative 1, negative 2, and negative 12. Okay. So we got a 1 in this position. Then you get zeros below it. So that's what we're going to be working on. Okay, so we ask ourselves, what do we multiply times this 1 that then added to the 3 would give us a 0 there? It's by negative 3. So we'll take negative 3 times row 1, and we'll add it to row 2 to give us our new row 2. Okay, negative 3 times 1 is negative 3 plus 3 is 0. Negative 3 times 1 is negative 3, and negative 1 gives us negative 4. Negative 3 times negative 2 is 6, plus a negative 1 is 5. Negative 3 times 3 is negative 9, plus 5 is negative 4. Negative 3 times 16 is negative 48, plus 18 is negative 30. Okay. Negative 3 times 1 is negative 3, plus 3 is 0. Okay, negative 3 times 1 is negative 3, negative 1 is negative 4. Negative 3 times negative 2 is 6, minus 1 is 5. Negative 3 times 3 is negative 9, plus 5 is negative 4. Negative 3 times 16 is negative 48, plus 18 is negative 30. That looks right. Okay, we'll take negative, see we have row the 1 here. We asked what do we multiply by to get a 0 here. We multiply it by negative 1. So I'll take negative 1 times row 1 and add that to row 3 to get us our new row 3. Okay, negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times 1 is negative 1, and 2 gives us 1. Negative 1 times negative 2 is 2, minus 3 is negative 1. Negative 1 times 3 is negative 3, negative 4 is negative 7. Negative 1 times 16 is negative 16, negative 9 is negative 25. Let me check. 0, 1, 2, negative 1, negative 7, negative 16. Okay, that looks right. And then our last one here. We need a 0 here, so I'll multiply this by negative 1 again. So I'll take negative 1 times row 1 and add it to row 4 to give us our new row 4. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times 1 is negative 1, and negative 5 is negative 6. Negative 1 times negative 2 is 2, 1. Negative 3, negative 5, negative 16, negative 28. Let me check. Negative 6, 1, negative 5, negative 28. Okay, that looks good. Okay, what we want now is we want a 1 here. Now you can swap rows. And I notice that my third row here has a 1 there. So I'm going to go ahead and swap row 2 and 3. So 1, 1, negative 2, 3, 16. I got 0, 1, negative 7, negative 25. 0, negative 4, 5, negative 4, negative 30. 0, negative 6, 1, negative 5, and negative 28. So I swap row 2 and row 3. Now let me double check. Okay, 0, negative 4, 5, negative 4, negative 30. 0, 1, negative 1, negative 7, negative 25. That looks good. Of course, I said that before, too. Didn't work out very well. Okay, so we got a 1 there. I want to get zeros below it. So let's work on that. Famous last words. Looks good. I was being so careful that this morning. I guess it's time for me to quit whining about that. Nobody's going to give me any cheese. Okay, so now I want to figure out what do I multiply times row 2 that I can then add to row 3 to get a 0 here. Well, if I multiply that by 4, 4 times 1 is 4 plus negative 4 is 0. So we're going to take 4 times row 2 and add that to row 3 to give us our new row 3. And I'll multiply by 6 to add to my last row to get a 0 there. So I'll take 6 times row 2 plus row 4 gives us our new row 4. Okay. 4 times 0 is 0 plus 0 is 0. 4 times 1 is 4 plus negative 4 is 0. 4 times negative 1 is negative 4 plus 5 is 1. 4 times negative 7 is negative 28, negative 32. 4 times negative 25 is negative 100, and negative 30 is a negative 130. Okay, and then 6 times row 2 plus row 4. 6 times 0 is 0 plus 0 is 0. 6 times 1 is 6 plus negative 6 is 0. 6 times negative 1 is negative 6 plus 1 is negative 5. 6 times negative 7 is negative 42, negative 47. 6 times, what is that? 6 times negative 25 is negative 150, plus negative 28 is negative 178. Okay, let me double check. 4 times row 2. 4 times that, 0. 0. 4 times that is negative 4, 1. 4 times that is negative 28, negative 32. 4 times that is negative... Okay, that looks right. 6. 6 times that... Yeah. Yeah. Negative 6, negative 5. 6 times that is negative 42, negative 5, negative 47. 6 times that is negative 150, negative... Yeah. Okay, that looks good so far. Well, our next step is to get a 1 here. Because we just finished with the second column, right here. Well, we got a 1 there, so that works out pretty good. So then what we want to do is we want to get a 0 below it. So let's go ahead and work on that. So I got 1, 1, negative 2, 3, 16. 0, 1, negative 1, negative 7, negative 25. 0, 0, 1, negative 32, negative 130. Okay. We ask ourselves, what do we multiply times 1 that we can add negative 5 to get a 0 there? Well, that'd be 5. So we'll take 5 times row 3, add it to row 4 to get us our new row 4. 5 times 0 is 0 plus 0, 0. 5 times 0 is 0 plus 0, 0. 5 times 1 is 5 plus negative 5 is 0. Calculator time. 5 times negative 32 times negative 32, and add that to negative 47. Negative 207. 5 times this, 0, 1, it's negative 160, negative 207. Okay. 5 times negative 130 minus 178, negative 828. Okay, negative 5 times that. That gives me 5, 1, negative 650, 750, 828. Yep, that looks good. Okay. Again, we're working with our diagonals. Diagonal 1's down, so this is our next place. We need a 1 here. Okay. We'll divide everything in this row by 207, or negative 207. So we'll take row 4 divided by negative 207, and that's going to give us our new row 4. Well, 0 divided by negative 207 is 0. 0 divided by negative 207 is 0. 0 divided by negative 207 is 0. Negative 207 divided by negative 207 is 1. And this divided by negative 207... 4? Yeah, 4. Okay, now let me write this down because I need to continue up above. One, 1, negative 2, 3, 16. 0, 1, negative 1, negative 7, negative 25. 0, 0, 1, negative 32, negative 130, 0, 0, 1, 4. Double check my signs. -2, 3, 16, 1, -1, -7, -25, 0, 0, 1. Looks good. Okay, so let's continue up here. So we've got 1, 1, -2, 3, 16. Got 0, 1, -1, -7, -25. 0, 0, 1, -32, -130, 0, 0, 0, 1, 4. And let me double check. Double check everything. Okay, that looks good. Okay, so we this is REF, by the way. This is row echelon form. Diagonal 1, zeros below it. Well, now we're going to start the bottom one here, and we're going to work at getting zeros in this place. So 0, 0, 0, 1, 4. Now I multiplied this by 32 to get a 0 here. So I'm going to take 32 times row 4 and add that to row 3 to give us our new row 3. Okay, so 32 times 0, 0 plus 0, 0. 32 times 0, 0 plus 0, 0. 32 times 0, 0 plus 1 is 1. 32 times 1 is 32 plus -32 is 0. 32 times 4, 128 I think, but let me plug in my calculator. 32 times 4, 128, plus -130 gives us -2. Double checking that. Okay, yeah, -2. Okay, now we need a 0 here. And I multiply this by 7 and then add it to this row. So I'm going to take 7 times row 4 and add that to row 2 to give me my new row 2. Okay, 7 times 0 is 0 plus 0 is 0. 7 times 0 is 0 plus 1 is 1. 7 times 0 is 0 plus -1 is -1. 7 times 1 is 7 plus -7 is 0. 7 times 4 is 28 plus -25 is 3. And let me check that. Okay, 28. That looks good. Okay, now I need a 0 here. So I'll multiply this fourth row by -3. It's always, in case you've already noticed the pattern, it's always the opposite sign of whatever's there. Like this is 3, so we multiply it by -3. Times row 4 plus row 1 gives us our new row 1. Well, -3 times 0 is 0 plus 1 is 1. -3 times 0 is 0 plus 1 is 1. -3 times 0 is 0 plus -2 is -2. -3 times 1 is -3 plus 3 is 0. -3 times 4 is -12 plus 16 is 4. -12, 4. Okay. Well, now we're working our way back up. We started this one, got zeros above it. So we're going to go to this next one, and we're going to get zeros above it. So we get zeros right there. Keep minus, has nothing to do with that there. I'm just out of space. Okay. 0, 0, 1, 0, -2. Now we're looking at this one here. You ask what do we multiply by that you then add to this get a 0. Well, that'd be, well, just add them together, I guess. So you're going to take row 3 plus row 2 gives you your new row 2. So 0 plus 0 is 0. 0 plus 1 is 1. 1 and -1 is 0. 0 and 0 is 0. -2 and 3 is 1. Let me look at that, double check it. Okay. Now we need a 0 here. Well, we multiplied this row by 2. Because 2 times 1 is 2, plus -2 is 0. So we'll take 2 times row 3 and add it to row 1. And that's going to give us our new row 1. Okay. 2 times 0 is 0 plus 1 is 1. 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus negative 2 is 0. 2 times 0 is 0 plus 0 is 0. 2 times negative 2 is negative 4 plus 4 is 0. Now let me double check that. 2 times that plus that. Okay. 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 And okay. Again, we're working our way up. We started with the first one, got zeros above it. We went to this one, got zeros above it. So we're at this one, and we want to get zeros above it. Zero, zero, 1, 0, negative 2, 0, 1, 0, 0, 1. Okay. We look at this one, we ask ourselves, what do we multiply by that then added to this gives us a 0? Well, multiply that by negative 1. Negative 1 times 1 is negative 1, plus 1 is 0. So we're going to take negative 1 times row 2 and add that to row 1 to get us our new row 1. Okay, negative 1 times 0 is 0, plus 1 is 1. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times 0 is 0, plus 0, 0. Negative 1 times 0 is 0, plus 0 is 0. And negative 1 times 1 is negative 1, plus 0 is negative 1. Double check that. Okay, we had 4 equations, 4 variables. So this first 4 by 4 should be a diagonal of 1s, 0s everywhere else. And it is. So that's a good sign. So our answer, in theory, should be the far right column in the order of our variables. If we look back at our equation, we had w, x, y, and z. So this would be w, negative 1. This would be x. This would be y. And this would be z. So w, x, y, and z. And that's our answer. Well, let's put this in the calculator and double check myself. I feel better. Before I was coming up like 55 over 131 or some kind of bizarre number. We need to put this into our calculator. So I'm going to come over here, go to my second, x and negative 1. Right arrow over to edit. This is where we always input our matrices. I'll do enter on A. Now the size of our matrix. This is 4 rows by 5 columns. So do 4 enter, 5 enter. And type numbers in. This is sometimes the hardest part right here. So 1, 1, negative 2, 3, 16, 3, negative 1, negative 1, 5, and 18. 1, 2, negative 3, negative 4, negative 9, 1, negative 5, negative 1, negative 2, and negative 12. Okay, let me double check all my signs. 2, 5, negative 4, negative 2. Well, 3, 5, negative. I should have my glasses on. Negative 2, negative 1, negative 3, negative 1. Mr. Magoo doesn't wear glasses for anybody, though. Okay. Now remember, we have to exit out, so you have to do your second mode. And we're going to go through our steps. So we'll go second, exit negative 1. Right arrow to math. And we want to up arrow to RREF. And then do enter on it. And then we'll go back into our matrix menu. Do enter on A. And then we do enter again. Now our first 4x4 is a diagonal of 1, 0s everywhere else. That means it worked. It's not one of our oddball cases. And does that match our answers? Negative 1, 1, negative 2, and 4. And that would be our answer. Again, you do not write this entire thing down as your answer like on a test. What I circled here is what you put down on a test. Now, of course, looking at this, you're sitting there, man, that was hideous. And he said that he spent an hour on it this morning and had to scrap his work. It's not that easy to do Gaussian elimination. It's not that easy to do Gaussian-Jordan elimination. If your instructor allows it, you should use the calculator. Calculator is much easier. And to be honest, these aren't meant to be done by hand, because when your equations become larger, it may take you 2 or 3 hours to do one problem. One simple math error, like I dropped a sign like this where this -7 is, I put a +7. One little mistake like that. It wasn't even a math error. I just didn't see a negative. And all of a sudden you got the wrong answers. Well, in the real life, you don't want those wrong answers. I mean, it's important for you to understand the theory behind it, but in reality, you're going to use some kind of technology to do it. And we're done with that section, and I actually made it through this time. So let me save this.